Doing a little bit more AP review. This is 2009B, AB for response number 6. So we're given a table. The velocity of a particle moving along the x-axis, is modeled by a differentiable function v, where the position x is measured in meters and the time t is measured in seconds. Selected values of v of t are given in the table. The particle is at position x equals 7 meters when t equals 0 seconds. Okay, so before we do anything, you're going to be asked to do two things from this table every single time. You are going to be asked to estimate slope, meaning the derivative of velocity, because this table's velocity. You're going to be asked to estimate the derivative of velocity by using the slope of 2 points on this table. Guaranteed, it's going to happen every single time. The other thing that's going to happen when you're given a table is you're going to be asked to approximate integration, right? So if you were integrating velocity, you'd be getting position. You're going to be asked to approximate that using an area approximation method. Trapezoidal, LRAM, RRAM, MRAM, it's going to happen. So when you're handed a table, think to yourself, yo, they're going to make me approximate a derivative. That's just old school slope. They're going to make me approximate an integral. That's just an area approximation. And they will be dumb specific about it. They'll have to tell you, use this many intervals, use MRAM, use LRAM. They have to do that. So if you look at this table and think, yo, that's 2 parts of these 4 problems, then you are absolutely right. So let's do this. Part A, estimate the acceleration. What? The derivative? I can do that. That's just old school slope. Of the particle at t equals 36 seconds, show the computations that lead to your answer. So they want the derivative at 36. Well, 36 is very conveniently located right between 32 and 40. So for part A, the acceleration at 36 is going to be approximately what happens if I do v of 40 minus v of 32 over 40 minus 32, right? Because this is the old school slope, right? Derivative and slope are related. They're the same concept. So when I plug these numbers in, right, I'm going to get a 7 minus a negative 4, so that's going to be an 11 over an 8. Remember the acceleration, so velocity was in meters per second, right? And time was in seconds. So acceleration is going to be meters per second, or more commonly we write meters per second squared. So again, they want you to show the calculation because they want you to communicate that you understand that derivative is essentially slope. So when asked to approximate a derivative from points, you are just approximating slope, old school algebra 1 slope style. Cool. All right, part B. Using the correct units, explain the meaning of the integral from 20 to 40 of v of t dt. Cool, we can explain that in a sec. In the context of this problem. And then, oh wait, here it comes, shocker, use a trapezoidal sum with 3 subintervals indicated by the data to approximate it. So this is another one we're asked to approximate area. So remember, if it helps you to think about it this way, that v of t is essentially x prime of t, right? It's the derivative of position. So this is going to be x of 40 minus x of 20, which this is the position at t equals 40. Right? And this is the position at t equals 20. So essentially what this is giving us, if we're going to communicate this, this is the displacement of the particle, right? So this is its displacement in meters, right? From t equals 20 seconds to t is 40 seconds. So this is the displacement, right? So this is the displacement, or you could say change in position, right? So change in position of the particle in meters. Okay, so let's, and we'll go through this in a second. I'll highlight the big things you have to mention. From t equals 20 seconds to t equals 40 seconds. So let's walk through the things you have to highlight here, right? So you need to say displacement or change in position, right? That's one. You need to mention that it's in meters. That's another thing, right? And then you need to mention the time interval that's being referenced, right? That's what we need to communicate when we're doing analysis for this stuff. So, okay, that's only the first half of the problem, though. The second half is the thing that I told you at the beginning of this video was absolutely going to happen. They want me to use this chunk of data and do a trapezoidal sum. Notice the heights of my trapezoids are not the same, so I can't use a shortcut here. I need to find the trapezoid from 20 to 25. Right, I'm going to find that area. I'm going to find the trapezoid from 25 to 32. I'm going to find that trapezoidal area, and I'm going to find the one from 32 to 40. So this value is going to be approximately 1/2. The height is the change in t here, so the 5, right, times the sum of the bases, which in this case will be the -10 and the -8, right? Plus the next trapezoid will be 1/2. The height here is from 25 to 32, so that's a 7, times the sum of the bases, which will be a -8 and a -4, so that's a -8 plus a -4. Probably didn't give myself enough room here, but we'll survive. Plus, the last one is 1/2 the height, which is 32 to 40, so that's an 8, right? And then the sum of the bases is a -4 plus a 7, right? So I want to show them that work because that's what they're going to care about seeing, right? They don't actually care how much work you need to clean it up. They couldn't possibly care less. It is a non-calculator section, so you're going to have to gut it out a little. It looks like most of these have at least one even number, so it's not awful. So if you were gutting this out, right, this is a -18, right? I'd put that with the -1/2 and realize that that's a -9 times a 5. So I get a -45 for the first one. Same thing here. This is a -12 times the 1/2, so I'd make that a -6, right? -6 times the 7, so I get a -42, right? And then this last one, this guy comes out to be a 3, but thankfully the 8 times the 1/2 is just going to be a 4, so I get a 3 times a 4, which is a 12. So I'm pretty sure that these guys come out to be a -30, so my final answer is that this thing is approximately -75. Now, go back to what you wrote that it was, right? It's the change in meters, right? So this is -75 meters, right? Essentially, what that's saying is that this particle moved 75 meters to the left as its net change in position over that time window. All right, cool. So those are the two predictable parts I told you that we're going to have. Let's keep moving. For 0 to 40, t is 0 to 40, must the particle change direction at any of the subintervals indicated by the data in the table? If so, identify the subintervals and explain your reasoning. Okay, so here's the thing. We need to make the mental connection. So we're talking 0 to 40, the whole table. We need to make the connection of what mental leap is happening if we change direction, right? So this is time for one of those flow charts, right? So when they say must, right? Must this thing change direction, right? And if so, what subintervals and why, right? So let's talk about what it means to change direction. So change direction means that v of t would change sign, right? Because velocity that's positive, if you're moving on the x-axis, positive velocity means moving right, negative velocity means moving left. If you were talking about the y-axis, positive velocity would be up and negative velocity would be down. So what we're looking for is, does v of t change sign? Like, must it, right? Must v of t change sign? Well, the thing is that there's only one way to guarantee something changes sign. And that's to say that on a given interval, it changes from positive to negative, right? That's the only way to guarantee it changes sign. I could change sign, so let's walk through this. V at 0, v is 3, and then becomes 5. Now, technically, velocity could change sign from 0 to 8. It's quite possible. Maybe somewhere in that window, my velocity went negative and came back positive, and that's totally doable. But it doesn't have to, right? However, when you look at the window from 8 to 20, well, the velocity at 8 was positive and the velocity at 20 was negative. There's no way that you change from positive to negative without changing sign. Like, that's the definition. So that must change sign means you want the windows where there's no way around it, you had to change sign. So from t equals 0 to t equals 8, right? I'm sorry, t equals 0 to t equals 8. Velocity is positive at both of those endpoints. I can't guarantee a sign change. But So the answer is yes, it does have to change sign, right? And let's walk through our answer, right? So v of 8 is positive, and v of 20 is negative, right? So there had to be a sign change, right? So the sign changed on the window from 8 to 20. That's one window, right? So that's one window. From 20 to 25, the signs are both negative. They stay negative. They don't have to change sign. They could change sign, but they don't have to. Same thing from 25 to 32. Both of those velocities are negative. I could have a sign change, but I can't guarantee it. But then here, from 32 to 40, we have another instance where, so the second time it's going to happen, v of 32 is less than 0, but v of 40 is greater than 0, so there has to be a sign change, right? There has to be a sign change on the 32 to 40 window, right? So let's go back and read the question and make sure we explain. So must the particle change direction in any of the subintervals indicated by the data? If so, identify the subintervals and explain your reasoning. If not, explain why not. So when I go to put my answer together in like a coherent way, I'm going to say it must change on the window. I like parenthetical notation, but it's fine if you prefer this, right? Just make sure you're using the correct variables. On the window from 8 to 20, and also the window from 32 to 40. Sorry, that's my bad. 32 and t and 40. Because... And then I'd probably just do this and be like, yo, I wrote this all down. V was positive, and then it was negative, and so on, right? So essentially, you have to explain that the velocity had to change sign in those windows. Okay, cool. This is actually the intermediate value theorem, right? IVT. So the intermediate value theorem essentially says that if you have a continuous function and you have a value below some number, like a value below 0, and a value above 0 on an interval, that somewhere in the interval between those two outputs you have to cross the x-axis. And similarly, it doesn't have to be above and below 0. It could be above and below some arbitrary number like 57, but essentially that the graph would have to cross that line. Cool. Part D. Suppose that the acceleration of the particle is positive from 0 to 8 seconds. Explain why the position of the particle at t equals 8 seconds must be greater than 30 meters. So this one's always a little bit tricky for people, but let's walk through it. So we know that the position at the start of this problem, right? So we know that x of 0 is 7, right? That was given. That's our part D. Okay, we know x of 0 is 7. We know that a acceleration is positive. So we know that a of t is greater than 0 on the window, right? So on the window from 0 to 8, right? So here's the argument. My argument is that so I know that the integral from 0 to 8 of v of t dt, right, is the same as the integral from 0 to 8 of x prime of t dt, meaning that is the same as x of 8 minus x of 0, right? So I know that essentially x of 8 is equal to x of 0 plus the integral from 0 to 8 of v of t dt, right? Cool. So here's my argument. X of 8 is equal to 7, because we know that. Plus, now here's the thing about this integral, right? So, since x prime, or since a of t, right? So a of t is positive. That says that v of t is increasing, right? What that means is that the minimum v of t on this interval is v of 0 equals 3. So let's pretend for a sec that this was a 3. If this were a 3, right? So this quantity must be, this must be bigger than what would happen if v was just a constant 3. Well, if v was a constant 3, then essentially I would get that this thing is a 3t evaluated from 0 to 8, meaning this is a 3 times an 8, right? That's a 7 plus a 24, meaning that x of 8, so x of 8 has to be less than 7 plus 24, meaning x of 8 is less than 31, right? And I know that x of 8 is, oh, I didn't mean less than, I take it back. Hang on, sorry, I'm slow. This value is bigger than this, meaning the actual x of 8, my bad, sorry, my brain is slow. X of 8 is bigger than a 31, right? And they asked me to show that that x of 8 is bigger than 30. Well, 30 is smaller than 31. So by simple math, x of 8 is bigger than 30. Sorry, my brain was slow in reverse things. So again, the logic here is that x of 0 is a 7, and that whatever this integral is, it has to be bigger than what would happen if I integrated the minimum v. The minimum v was just a 3, so I get that whatever this integral is, it has to be larger than a 24. So x of 8 has to be larger than 7 plus 24, which is larger than 31, which is larger than 30.